Good day, learners! Today we are going to discuss logical operator disjunction in logic part 4. But before anything else, do not forget to like, share, subscribe, and hit the notification bell so that you will be notified for my upcoming videos. Thank you!
Dos, tres, cuatro.
Logical operator disjunction in logic part 4. If P and Q are propositions, their disjunction is the statement P or Q. It is denoted by proposition P and the symbol inverse caret and proposition Q. This is the truth table for the disjunction. As the table shows, the disjunction statement P and Q will only be false when the proposition P and Q are both false, otherwise true. Let us have an example. Translate the disjunction statement P or negation Q into a sentence and find the truth value of the disjunction statement. If P defined by the statement 2 plus 5 is equal to 7 and Q defined by a statement a trapezoid has two pairs of opposite parallel sides, how are we going to translate now the given logical symbol into a statement? So this is our logical symbol P or negation Q. The symbol P or the proposition P will be replaced by the statement 2 plus 5 is equal to 7, and the symbol inverse caret will be replaced by the word or, and the negation Q will be replaced by the statement it is not the case that a trapezoid has two pairs of opposite parallel sides. Then we can say that the statement of the given logical symbol is 2 plus 5 is equal to 7, or it is not the case that a trapezoid has two pairs of opposite parallel sides. How to evaluate the truth value of the logical symbol P or negation Q? So what we need to do, identify first what is the truth value of proposition P and what is the truth value of proposition Q. By the statement 2 plus 5 is equal to 7 of proposition P is true, while the proposition Q defined by the statement a trapezoid has two pairs of opposite parallel sides is a true statement. After that, we have to plug in the truth values for P and Q into our logical symbol. So we can say true or negation true, we have to evaluate first the negation true, so that the negation of true is false, then the updated logical symbol with its truth value is true or false. Or based on the disjunction truth table, when P is true and Q is false, the disjunction statement of P and Q is true. Then we can say that the statement P or negation Q is a true statement. Example number 2. Evaluate the compound proposition negation P or Q for the truth values P is true and Q is false. The given statement is negation P or Q. The first step we need to do is substitute the truth values for P, which is true, and the truth value for Q, which is false. Then this is now our updated statement, negation true or false. Next, as what you can see, there is a negation P, and we have to evaluate first the negation P based on the truth table for negation. So as the table shows, when P is true, the negation of true is false. Then this is now our updated statement, false or false. As what you can see, we have now a disjunction false and false. Okay, we have to evaluate the disjunction false and false based on the disjunction truth table. And it shows in the table that when proposition P and Q are both false, the disjunction statement P and Q is false. Then we can conclude that the compound statement negation P or Q is a false statement. Example number 3. Evaluate the compound proposition, the quantity of P and Q, or the negation of the quantity P and negation R. For the truth values, P is equal to true, Q is equal to false, and R is equal to false. Okay, the solution. Okay, we have to write the given statement, the quantity of P and Q, or the negation of the quantity P and negation R. So we have the first step we need to do is to substitute the truth values for P, which is true, Q, which is false, R, which is false. So our statement becomes the quantity of true and false, or the negation of the quantity true and negation false. As what you can see, there is a negation inside the parenthesis in the second group. So we have to evaluate first the negation of false based on the truth table. When the proposition P is false, the negation false is true. As we are going to update now our statement, that is the quantity of true and false, or the negation of the quantity true and true. And the next thing we need to do is we have to evaluate the logical operators inside the parentheses. So we have to evaluate true and true, and also the conjunction of true and false. Based on the conjunction truth table, when P is true and Q is true, the conjunction of P and Q is true. And when P is true and Q is false, the conjunction statement P and Q is false. So as we are going to update now our statement, it becomes false or negation true. Then as what you can see, there is a negation for true. We have to evaluate negation true. Based on the negation truth table, when proposition P is true, the negation P is false. So as we are going to update our statement, it becomes false or false, or the disjunction of both false. So based on our disjunction truth table, the disjunction of false and false is false. Therefore, we can say that the given statement, the quantity of P and Q, or the negation of the quantity P and negation R, is a false statement. Example number 4. Write the logical symbols and evaluate the truth value of the given statement. The statement is 5 less than 2, and it is not the case that negative 2 is less than 4, or a decade is 10 years. Okay, the solution will be, we have to let P be our proposition, 5 is less than 2, which is a false statement, and let proposition Q be defined by the statement negative 2 is less than 4, which is a true statement, and last proposition is the proposition R, defined by the statement a decade is 10 years, which is a true statement. So how we are going to translate now the given statement, so we have to dissect the statement and replace by its corresponding symbol or proposition. 5 less than 2 will be replaced by proposition P, and the word and will be replaced by the symbol caret symbol, and the statement it is not the case that will be replaced by the symbol tilde or the negation symbol, and negative 2 is less than 4 will be replaced by the proposition Q, and the word or will be replaced by the symbol inverse caret, and the statement a decade is 10 years will be replaced by proposition or. Therefore, the logical symbol of the statement is P and negation of the quantity Q or R. Then how are we going to evaluate the truth value of the statement? So what we need to do, just substitute the truth values for P, Q, and R respectively. So we have F and negation of the quantity true or true. So as what you can see, the disjunction of true and true is being closed by a parenthesis, which means that we have to evaluate first the disjunction of true and true. So based on the disjunction truth table, when proposition P is true and when proposition Q is true, the disjunction of the statement P and Q is true. Then as we are going to update our statement, it becomes false and negation true. And that's what you can see, the true here is being negated. Then we have to evaluate first the negation of true based on our negation truth table. So it shows in the table that when the proposition P is true, the negation of P is false. As we are going to update our statement, it becomes false and false. As what you can see now, we have now the conjunction of false and false. So we have to evaluate now this one using the conjunction truth table, and it shows that when P and Q are both false, the conjunction of P and Q is false. Okay, then we can conclude that the statement 5 less than 2, and it is not the case that negative 2 is less than 4 or a decade is 10 years, is a false statement. And that ends our video discussion at this moment. Thank you for watching. But before you will end this video, please do assess your learnings by answering the self-test activity. Thank you.